Welcome to the OSF STEAM channel. My name is Luke. Today, we're taking a look inside one of the most innovative kits yet, biomedical engineering. Biomedical engineers work at the intersection of medicine, science, and technology to create devices and solutions that help improve patient care and save lives. In this kit, students will get a hands-on experience with some of the same engineering concepts used by real biomedical engineers. In this experiment, we're specifically going to make a homemade LVAD machine. We're going to unbox this kit, take a look at all of the materials included, and show you what makes this hands-on STEAM experience so unique. Getting the box open, you are immediately greeted by the instruction guide. This walks students step by step through the activity and explains the biomedical engineering concepts they'll be exploring. Through this guide, students will learn how engineers use creative, problem-solving, and scientific principles to design solutions for real-world healthcare challenges. Inside, you'll also find an information packet that includes access to a pre-recorded demonstration of the activity. This can be especially helpful for anyone who wants a step-by-step guide to follow along with during the project. Now, let's take a look at all the materials included in the kit. First, safety is the most important part of every experiment, so we have a pair of safety glasses to help protect your eyes. Next, we'll be looking at all the tools that you'll be working with throughout the experiment. First, we have a pair of scissors. These will be used for cutting objects during the experiment. These don't look sharp, but be careful because they can cut you. After that, we have a large toolkit. After you get it unwrapped and opened up, you will see many different tools that we will be using today. On the far right, we have a pair of needle nose pliers. These will be used to grab smaller items and can be used to create torque. Now there are a few parts of these pliers to keep note of. The front end have little teeth, which are used to squeeze and grip objects. And this part here is actually a wire cutter. It's very sharp and it will cut you if you get your finger caught in there. Also, be mindful of this section of the pliers, as it's really easy to accidentally get your finger caught and pinch yourself. Now the needle nose pliers do have a wire cutting feature, but next to them in the case are a pair of actual wire cutters. We won't be needing these for today's experiment, but they are included with the kit. And again, they are very, very sharp, so just keep that in mind for future use. And then next to those is a pair of tweezers. These will be used for picking up small objects. In the middle, we have a magnetic handle which will be used to attach various bits to. And here are the various bits that are included in the set. You just pop them out of the holder and attach it into the handle like so. Now this is a specific square bit, and this square bit can be attached to this extension rod. This allows you to reach screws in harder to reach places. And then using the end of this extension rod, you can also attach several different sized socket heads. These can be used for nuts and bolts. On the left side, these are precision screwdrivers which can be used for smaller screws. Next, we'll be looking at all the components you'll be using to execute the experiment. First, we have a battery box. This will be used to power your experiment. Notice there is a screw taped to the front of the battery box, and this is really easy to lose track of, so just keep an eye on it. You will also notice that there is no batteries in the battery box. And that leads us to our next item, which is a pack of batteries. You can remove these from the plastic and insert them in the battery box. Next is this baggie, which includes a tiny DC motor, as well as some 3D printed fan blades which you can use to attach to the motor. This will be used to pump the water through your homemade LVAD machine. There should also be a black and yellow wire included that have alligator clips on both ends. These will be used to connect your motor to the battery box. There's also a T-shaped pipe connector, as well as a clear piece of tubing. Your tubing will be inserted into both sides of the T-shaped pipe, and the motor will go into this section here. Now there are several balloons included in this kit. These will act as a seal between your pipe and your T-shaped connector. These are latex balloons, so if you have a latex allergy, try to avoid using them. Instead, there is some modeling clay which can be used as a substitute. There's also a roll of electrical tape which will be used to secure the tubing to the connector. Next is a small container of food coloring. This will be used to dye your water in order to give it that deep red color of blood. There is also several pepper packets. These will be dumped into your blood mixture to visualize the way your blood is pumped through the LVAD machine. And last but not least, there's a square sheet of silicone. This will be used to cut out the shape of a heart in order to help visualize how the LVAD machine attaches to a patient's heart. Once you have all of your materials organized and ready to go, you'll be prepared to begin the activity and start thinking like a biomedical engineer. And that's a look inside the OSF STEAM Biomedical Engineering Kit. If you'd like to explore more hands-on STEAM experiences, be sure to check out the other kits through OSF STEAM. Don't forget to like this video, subscribe to the channel, and let us know which kit you'd like us to unbox next. Thanks for watching, and we'll see you in the next experiment.